Yeah, hello and welcome to page 4 of the notes. Example 6, solve the following differential equation e to the x plus e to the negative x dy over dx equals y squared. Again, first thing we do is separate variables, so we'll bring all of our y's to the left, all of our x's to the right. When we do that, we're going to get dy over y squared is equal to, and then we have e to the x plus e to the negative x in the denominator times dx. Now, on the left-hand side, that's not hard to integrate. We can go ahead and make that y to negative 2 dy. Integrate the left side. When we do that, we're going to get negative 1 over y. On the right-hand side, though, you can't tell just by looking at it, if we try to integrate it how it is. But what we can do is change the way that it looks. In order to change the way that it looks, we're going to multiply by 1. So we're going to multiply to the right-hand side by e to the x over e to the x. When we multiply the right-hand side by e to the x over e to the x, we're going to get e to the x in the numerator. In the denominator, e to the x times e to the x is e to the 2x. Or we could also say e to the x squared. And again, it's of this form because I'm going to show you how it looks like an identity. E to negative x times e to the x, that's just going to be 1, so plus 1. And we have dx on the outside. Now we'll go ahead and try to integrate this. And we can integrate this. We realize that this is an identity with one of our trig functions. It's going to be an inverse trig function. And we can take the integral e to the x over e to the x squared plus 1 by using the inverse tangent function. So we have inverse tangent of whatever our function is over here, which is e to the x. And then we have plus c. And after we've written it this way, all we have to do now is just solve for y. This is already solved for if we're looking for an implicit solution to the differential equation. It's solved, but what we can do is write this explicitly as well. Explicitly is when we solve for y. So let's go ahead and do that. All we're going to do is flip the equations on the left and right, and we get negative y is equal to 1 over inverse tangent. You could also say arctangent e to the x plus c. Get rid of that y by multiplying by a negative, so y is equal to negative 1 over inverse tangent e to the x plus c. Again, the way that I notice, okay, I need to multiply by an e to the x over e to the x is realizing that I cannot integrate this the way that it looks itself. So what I'm going to try to do is I'm going to try to change it to a format that I do know. I do know that the inverse tangent is just the derivative, over whatever the derivative of the function is, squared plus 1. All right, now this is our solution explicitly, and what we have been doing is, I've been showing you methods of the implicit solutions or explicit solutions. Implicit solution is just solving the differential equation. Once you get rid of the derivatives part, you solve the differential equation. Explicitly is when you actually have to solve it for y. So that's what we're going to do for this last problem. Example 7, we're going to solve the differential equation x dy over dx is equal to 2y minus 4. And so the first thing that we're going to do to both sides is separate the variables. So on the left-hand side, I'm going to go ahead and divide by y minus 4. On the right, I'm going to go ahead and divide by x, and then put the dx to the right side. Now, let's go ahead and integrate the left side and the right side. The integration here is not bad. We have the integration of dy over y minus 4 is just natural log y minus 4. On the right-hand side, it's just 2 natural log absolute value x plus c. Now, since we're trying to solve this explicitly, we've got to solve this for y. So I'm going to rewrite my natural log on the right-hand side to get rid of that 2 that's in front. And again, properties of logarithms says that I can go ahead and put any coefficient of a natural log and make it the power of whatever is inside that log plus c. And now what we're going to do is go ahead and take the exponential to both sides. When we take the exponential to the left-hand side, we get y minus 4. on the right hand side, when we take the exponential, we're going to get e to the x. The e and the natural log is going to cancel out, so we're going to get x squared, but we still have this times e to the c because of that addition in the exponent. So it's y minus 4 is equal to just x squared e times e to the c is just a constant, so we're going to write c in front. Get rid of that minus 4 by adding 4 to both sides, so we get y equals c x squared plus 4. And there's our solution to the differential equation explicitly.